the planets. Through history, people have found many ways to explain the mystery of the night sky. Some imagine that it was a blanket with holes that let in the light of heaven. The Navajo of North America believed that the god Sohano'oi carried the sun on his back and at night hid it behind the west wall of his house. The Japanese believed that the moon was born from a tear shed by the god Dizanaji. But what science tells us about the birth of the solar system is also astounding. 5 billion years ago, from a swirling mass of cloud, the sun was born. At its center, the heat and pressure triggered a nuclear explosion that has been going on ever since, the source of the sun's energy. At the same time, the outside of the cloud began to form into the planets, dense rocky ones nearest the sun, and at the far reaches, much bigger creations, mostly made of gas. The sun with the 9 planets orbiting around became our solar system. The sun is big enough to hold more than 1 million Earths. From the surface, raging at over 10,000 degrees Fahrenheit, giant solar flares leap tens of thousands of miles into space. Distances in space tax our imagination. A journey in a passenger jet from the sun to the outer limits of the solar system would take over 800 years. Even in a science fiction spacecraft traveling at the speed of light, the voyage would still take over 5 hours. To reach the nearest star would take 4 light years. Heading out from the sun, the first planet is the tiny, battered Mercury. A sphere of rock the size of our moon, Mercury is a planet of dramatic extremes. The sun's massive gravitational pull has robbed it of nearly all its atmosphere. During the day, the temperature quickly rises until it's hot enough to melt most metals as if they were wax. But at night, with no protective atmosphere, the temperature plummets until it's as cold as liquid nitrogen. The sun's gravity also attracts passing asteroids and meteors. Close by, Mercury gets battered and scarred with huge craters. Mercury only takes 88 Earth days to orbit the sun, giving it the shortest year in the solar system. But it spins on its axis so slowly that its day, strangely, lasts twice as long as its year. Since the orbit is so short, it passes through our night sky with great haste. So in the Roman pantheon, Mercury was the messenger of the gods, a symbol of agility and speed. Viewed from the Earth, the planets helped to govern our sense of time. The solar system provided a calendar to tell early humans when to sow the seed and when to reap the crop. For travelers and sailors too, a knowledge of the heavens provides a reliable direction finder. With eyes as their only telescopes and minds as their only calculators, ancient people still managed to map and record the heavens. 6,000 years ago, the Chinese made detailed records, data that's still used today. They predicted celestial events of great significance to the emperor and his court, phases of the moon, the positions of the planets and eclipses, all with unerring accuracy. They had to. The punishment for being wrong was instant execution. In early cultures, the astronomer was half scientist, half magician. After all, someone who could predict when and where the sun would rise could surely foretell other events. Astrology, fortune-telling from the positions of the stars and planets, still thrives. Even monarchs and political leaders have consulted astrologers when making important decisions. The second planet out from the sun is Venus. Named for the Roman goddess of love, it is a symbol of all that is gentle. It's the brightest planet seen from the Earth, often visible at dawn and dusk. It's been called the morning star, the evening star, the dragon star, the witch star. But the beauty of Venus is deceptive, with conditions more awesome than any dragon, more terrifying than any witch. Its brightness comes from a toxic atmosphere reflecting the sun's light, a mixture of carbon dioxide and sulfuric acid. The planet suffocates in an extreme form of the greenhouse effect. A computer can simulate a flyby of the surface of Venus, which is whipped by colossal storms with hurricane-speed winds and a rain of burning acid. Lava flows come from what appear to be permanently active volcanoes. A brimstone and sulfur world, the nearest you can get to hell. Land a familiar object on Venus, and it would not last very long. Acid rain and extreme temperature would burn holes through the metal. And before long, high winds would blow it away, a real challenge for an exploring probe. Only one has survived long enough to transmit data back to Earth. A Russian probe was specially strengthened to withstand the awful conditions. Even so, it lasted no more than an hour. The Earth is about the same size as Venus, not much further from the sun. So why don't we fry in lava flows and choke on sulfuric clouds? Part of the answer is on Earth there's life. 4 billion years ago, the Earth was much like Venus, with immense volcanic activity shrouded in carbon dioxide and water vapor. But as the Earth matured, the water vapor cooled, and it rained. Rain enough to create the oceans, the birthplace of primitive life forms. These microscopic creatures began to break down carbon,